Welcome to Calbeckistan, a place where anybody can learn math. I'm Mr. Calbeck. Today we're going to be talking about parallel lines. So I'm going to draw a couple of parallel lines in here, and we'll talk about the different angle relationships that you can find and see what happens. We had a couple of parallel lines here, and I've tried to do it on graph paper so that they're as straight as possible so we can see these relationships. And now I'm going to draw another line through these two. If there's another line that intersects two parallel lines, we call it a transversal. And I'm going to be really specific about how I go about graphing this so that you can see how the relationships work. And if you remember from Algebra 1, you can graph a line based on the slope of it. So I'm going to try to graph this with a slope of -1/2. And we're going to see if I can get that to be straight throughout everything here. I think it should be about right. So I do this so that we can see how the angle relationships work with these new lines. So this is called a transversal. Now, hopefully what you can see here is that there's a bunch of angles that have been created now. With parallel lines, there's not really any interesting angles worth talking about, but now I have a whole bunch. So if we look right here, you can see the ones that we've talked about in other places in geometry. So you've got your vertical angles, right here, right here. You've got linear pairs, so I have lines that make up a line, and they're going to add up to 180. The word for that is supplementary. But I want you to see some other things here. One of the ways that you can actually measure angles, we don't talk about it very often in geometry, we do in algebra, is that you can measure by the slope. And I want you to see some really cool things here. If I look here, here's the vertex of an angle. I'm going to use a different color here so you can see better. I am going from this horizontal line, I'm going to go over 2 and up 1 right here. And I've got that angle there. Now I want you to see something over here that's really interesting. Not only do I have a over 2 up 1 angle here, but look at this down here. Another vertex, another angle, and I see the exact same angle show up. To be over 2 and up 1. This angle is identical by slope, and it also is identical with the number of degrees that make up that angle. So if you care, this angle is actually 30 degrees. And you'll learn later in this class why I know that. But for right now, you can just accept it. Now, if I know this is a 30-degree angle, that's a 30-degree angle. This right here is a linear pair, so we can just subtract from 180 to find the other one. This one over here's got to be 150. But here's the other really interesting thing. Over here, this is also 30, so that means this angle is now also 150. This one over here. I think it's amazing that when we have a transversal that goes through two parallel lines, we've actually got a whole bunch of angles that are going to be equal. So what we have here is this is an example of something called a corresponding angle. Now, if we look at this first group of angles, there's 4 angles here. The top left one is 30 degrees. The position is important. The top left one is 30 degrees. The top left one in the second group of angles is also 30. Since they're both in the top left, the same place in these two groups of angles, we call them corresponding because they're in the same place. Corresponding angles in this situation are always going to be congruent. And that's one of the many theorems we're going to be talking about today. So if you haven't started taking notes yet, please do so. Now I've got a couple of other things we can see here. Again, this 150 would also be another set of corresponding angles. This 150 right here is the top right angle in this group of 4. This one is in the top right in this group of 4. And again, corresponding angles are always going to be equal. Some of you may be noticing, like, Well, wait a minute, Calbeck. We actually got some other angles that are equal. And I'm hoping you notice this. We see 30 degrees across from this one. These are vertical angles right here. Vertical angles are always congruent. We know that from the vertical angle theorem. There's a whole video that I did proving that that's true. So that's got to be 30 degrees. You can also see it from the slope. Again, we see over here, it's going to be down 1 over 2. Exactly the same measure as those other angles. And we see that same thing happening over here. Got an angle here, it's also 30. But that means we've got some interesting things going on here. We have the 30 here and then the 30 here. These are equal even though they're not in the same place. They're not corresponding angles. There's actually another name for these. And so I'm going to talk about this for a second. So this is a transversal. And there's some important words when we're talking about the position of angles. One of them is the word alternate. So alternate means opposite sides of the transversal. So you can talk about the position with respect to the transversal, but I can also talk about the position with respect to the parallel lines. Both of these angles are in between the parallel lines. So the way that we talk about these is they are alternate because they're opposite sides of the transversal, interior because they're between. So these are alternate interior angles. And they're always congruent. So you can start to see, though, that there's some other pairs of angles that we see that are congruent already. We have this 30 is congruent to this 30 up here. Those have a name as well. Hopefully you already learned and wrote down in your notes that these are alternate, but they're not between the parallel lines. So there's a different word to describe those. Since they're not between these, they're on the outside. Again, you can kind of think about it as interior. And then out here, we would call that exterior. So these are alternate exterior angles. So far we have corresponding, alternate interior, alternate exterior. Now you can also see some other possible relationships. Now I've got this one right here. So I've got 150 and 30. These are not the same. They're not congruent like the other relationships that we looked at. But there is a relationship here. These add up to 180. It's a very important relationship in geometry. So that is an important relationship as well. So we have a name for these angles. They're on the same side of the transversal. Notice they're not alternate this time. So we say that they are consecutive. They're in a row. They're on the same side. So they're consecutive and they're in between, so they're interior. Consecutive interior angles. And you can also see that same relationship holding up here. I've got a 30-degree angle here and a 150 out here. So I have consecutive, and they're on the outside of the parallel line, so these would be consecutive exterior angles. So these are the different relationships that we have. Corresponding, alternate interior, alternate exterior, consecutive interior, and consecutive exterior. And if you're paying attention, you notice that there's some relationships for the angles. Consecutive, corresponding, are always congruent. What's that? Oh, is it squeaking? No, that's okay. Or my floor is squeaking, so whatever. If the camera girl was maybe a little bit more careful, then maybe we wouldn't have some squeaks here. So we have alternate, and if you notice, the alternate are always congruent. So we have alternate interior, alternate exterior, they're always congruent. Consecutive angles, so consecutive interior, are always supplementary. And the cool thing about parallel lines is all of the angles are either going to be congruent or supplementary, so you can use your intuition. Did they look congruent? Yeah, then they're probably congruent. If they look supplementary, they're going to be supplementary. There are theorems that go with all of this. I'm going to put a slide up on this video right now so you can see them. But again, please take these notes. We can go ahead and take a look at what this might look like in a problem as well. Hold on, I got to do a little paper change here. Insert elevator music here. Can be measured with a slope of 1. Let's see how good I did on that. Not great.
We're all watching you.
I know you're watching me. I'm just trying to get a good angle. All right, so let's look and see here what you might see in a math problem at home. And we'll just do a quick one. So might have something like this. Instead of giving you angle measures, it might write like, hey, this is 3x minus 3. This one is 7x plus 23. Okay, and then they might ask you to find the angle or solve for x or something like that. Make sure you read the problem carefully though, because sometimes they're going to ask you to solve for x, sometimes they're going to ask you to find the angle measure, which are different questions. So a lot of people make mistakes on tests because they don't read the question carefully. There's a couple things you need to do here. First, you need to know if these lines are parallel or not. If it tells you in the problem they're parallel, that's great. The symbol that you look for to determine whether things are parallel is these little arrows that go right in the middle of the line. That tells you they're parallel. If they're parallel, all those relationships we just talked about apply. So these would be consecutive angles because they're on the same side, and they're consecutive interior angles, which tells me that they are supplementary. So if I want to solve these, I would say, all right, these have to add up to be 180. So I'm going to say this is 3x minus 3 plus the other angle, 7x plus 23, equals 180. And we can just go ahead and do the math from here. Combine like terms, you got 10x. Combine like terms again, you got 20 equals 180 here. Subtract 20. And we're about done. So we get x equals 16. Now, if that's what the problem is asking you to find, make sure that you say, oh, x is 13 or 16. But sometimes it's going to ask you to find the angle. So if I want to find the angle, I've got to remember to plug it back in. So I would say, oh, that's 3 times 16 minus 3, and figure out what that angle equals. And this one, that's 48 minus 3, or 45, which I already told you at the beginning. So it's not really that exciting of an answer. But once you know one of these angles, you can actually find all the rest of them. I don't actually need to do any more math on here. I know they're supplementary, so this has to be supplementary to 45, so this is 135. I know this is a linear pair, so this has to be 45. And it's corresponding, so it has to be 45. Alternate interior angles, this one has to be 135. This one has to be 135 because it's vertical angles. These are vertical angles, and these are vertical angles. So you can actually find all of the angles of the 8 that are made with a transversal just by finding one of them. Make sure that they're parallel though, because if they are not parallel, you can't do any of this. So that's the trick. That's the way this works. Once you know these angle relationships, it can save you a ton of math and a ton of time because you can just suddenly plug all these things in. All right, that's all I've got for you guys today. We will be talking about proofs on this later, so stay tuned. See you guys next time. It's not a great angle, it's a good angle, but that's okay. Better than an acute angle.